Thank you very much. Well, yeah, actually, I will focus on the features that are new to MoGraph. The original title was Cinema 4D MoGraph Motion Graphics Made Easy, but I adjusted it a bit because I want to focus on the new stuff. So now it's MoGraph in R20, powerful tools for awesome effects. So for those of you who don't know MoGraph, what is it? Well, actually, for me, MoGraph is the tool because it's so flexible and you can use it in so many ways. But it is the tool to generate clones, object clones, and to control them. So you can create millions of object clones out of one object or multiple objects and then control them very easily. But what is new to R20 regarding to MoGraph? Well, there are three features that I want to show you live here. And the first one is the new multi-instances, which are, well, a new type of instances that are very efficient, so you can really handle millions of clones in the viewport directly. I will show that to you in a minute. Then we've got the new MoGraph fields, and MoGraph fields are actually a replacement for all fall-offs that you have inside of Cinema 4D. So everything that has something to do with a weight is now replaced by fields and can be controlled using fields. And last but not least, I also want to show you volume modeling. And yeah, modeling with voxels with the OpenVDB library. And this is actually a model that I want to create for you later. Okay, so let's jump into Cinema 4D. And therefore, I switch here. And I want to start with showing you the multi-instances. And here I have a setup that is not very motion graphic-like, but it shows the power. So here we've got a scene, yeah, like a crowd simulation, so to speak, but a static one. And let's have a look at the models here. If we go to the object informations, so this model is around 20,000 polygons. The next one is around 100,000 polygons, and the couple here is even 200,000 polygons. So on average, we have models here that are 60 to 70,000 polygons. And yeah, we clone them, and you know that from previous versions of Cinema 4D, at some point when you hire the count of clones, then you see that the viewport gets a bit slow. But what we can do now is we can change or adjust the instance mode not to be render instances, but multi-instances. And with multi-instances, in the beginning, you don't see much of a difference as you move the viewport here. But you can set the viewport mode to be something different. So in a way that not every single polygon has to be calculated. You can reduce all of these objects here just to be represented by their bounding box, by their matrix, by their points, or you can completely turn off viewport representation. And I want to adjust it to be bounding box for now, and you see that it's incredibly fast. So let's bring up the count here, maybe to 100 by 100, and zoom out a bit, and let's hit render. And you see that it almost immediately starts to render, and it goes really fast. I mean, I'm on a mobile device here, and it just renders. So maybe let's bring the count up a bit, maybe to 500 by 500,000. Oops. Just like this. So now we've got 250,000 clones. You see that even with bounding box representation, it drops some frames, but we can bring down the viewport mode here, the viewport representation, to points, And once it has turned into points, you see that we can just move the viewport camera as there was nothing in the scene. And now, well, let me just overdo it a bit and use 1000 by 1000 clones, which equals 1 million clones. And we zoom out a bit once they are calculated. And you see, we come to the point where we even have the viewport clipping here. And let's just hit render. So now it will take some time, some preparation time here, but it will be pretty fast. So I think after around 15 seconds, it will start to render. And there you go. We are rendering 1 million people here. What you see is just a noise, but it's 1 million people. Okay. That's the multi-instances scene that I wanted to show you. Let's jump into the next topic, and this is fields. A topic that I really love because fields are a very powerful tool. I think they are actually the most powerful tool that we released in the last 5 to 10 years or so. So what fields are fall-offs on steroids. So fields are separate objects in the object manager, and this way you can also move the fields separately from the effectors they are applied to. Okay, let me recreate this field setup here so I can show you how this can be done. Let's get rid of those fields and also delete the fields here in the effectors. And then you see how the scene is built up. So we've got a torus. The torus has got a vertex map on it. You see there is a vertex weight here. Then I cloned some matrices onto that torus. And next there is a plane effector. And this is the first thing we want to mask using the new fields. So if you have a look at the plane effector and have a look at the tabs, there's the basic tab, the coordinates tab, effector tab. Nothing has changed in these tabs. So it's the fall of tab only where we made some changes, but very, very powerful ones. So instead of having a single fall off here, we have a list. And this is actually a layer-based system where you can layer up fall offs. So let me create a box field first. And now you see we've got an entry for the box field. So this is our first layer. We can deactivate it, activate it. We can deactivate the values of the effector, so the parameters you set up here, like position, scale, rotation, and so on. And we can activate or deactivate the color separately. We have blending modes, like you know from image editing applications, and an opacity slider. Then, within the field, if it's selected, there is a remapping tab, so you can just remap the whole thing. Maybe let me make the attributes manager a bit bigger. You can adjust the contour here. Right now, the contour mode is set to none, which means it's linear. But you can also set it to step, for example. Then it will create steps. This also looks very nice if you use it with a noise field or a random field. And we also have curves here. So you can adjust the fall-off or remap the fall-off by using the curve here. And then we also have color remapping here. I will come to that later. Yeah. So here we've got one of the advantages of fields. Fields are separate objects, which means I can scale that field and I can rotate that field. But I apply these changes to the field only and not to the effector it is applied to. Okay, so let me just create a little field setup. The next field I want to create is for colorizing the whole thing. So you can really colorize MoGraph setups just by using fields. And therefore, I create a solid field. And the solid field should not affect the position and rotation and scale of the clones, but the color. We make it the background layer. And we set the color to be, to be blue. Then we go to the box field and set this to add. So you see that there is some colorization going on here. Okay, the next thing I want to do is I want to drag and drop the vertex map into the fields list. So you can also create a fall-off by dragging and dropping a vertex map into the fields list here. This should affect the color only. So let's enable remapping here and enable the color remap. Adjust it to be something like that. So you see, this is also stored in the field. And remember, we are just having one plane effector active here. So this is all controlled by one plane effector. Even if I create another spherical field and move it to the side maybe, scale it down and adjust the fall-off here in the remapping, it's just one plane effector, and this is really awesome. So I can move the fields around separately, but as I told you before, it's just one plane effector. So what if I want to use one fall-off in multiple effectors? That's possible, absolutely. So maybe let's just right-click on the field parameter here, on the field list, and choose copy. Then go to the random effector, choose paste, and enable the random effector. And you see that the randomness is applied to the areas of the fields only. So by moving this one field here, or by adjusting this field here, you actually control the fall-off of multiple effectors, which is very powerful. Okay. So let's go to the next setup that I created. Actually, a setup where I want to explain fields a bit more. Fields are really a unified weighting system all over Cinema 4D. So what we have here is some clones that are nulls. And then you've got the fields here. This is the spherical field. And once you move it or scale it, you see that the values adjust. And in the middle, there is the 1, which means 100% weighting. And outside, it's 0% weighting. And here in the middle, it's a weighting between 0 and 100%. The good thing here is that you can place those objects, those fields, somewhere in 3D space because they are separate objects. And then you can make a cloner setup, for example, move through 3D space, and it will react to the weighting of the fields based on what you want it to do. Okay, that's what fields are, a unified weighting system. But you can do much more than just controlling weights for MoGraph with it, because it's a unified system. So let me check what comes next. Yeah, we want to create a growth effect. So something like this. It's very simple, but already a bit impressive. So let me recreate this. This is all based on vertex maps. Let me just delete all of the effectors and the vertex maps. So we've got the clean scene, and I also want to deactivate the cloner here. And then we select the plane, and there are already 3 vertices selected. And when I press V, I bring up this menu here, and I go to select and set the vertex weight. And I set the vertex weight for these 3 vertices to 100%. So this is my vertex map now. I created a weight map, and now I want to use fields with it. So let's select the vertex map. And then you've got this nice Use Fields checkbox here. Enable it, and you will have a list with a freeze field, and the freeze field stores the values in it that have been there before you created the freeze field, in this case. Okay, but what you can do is you can also create other fields here and control your vertex map with them. So what fields also are is easy to use vertex map tools. Just create another spherical field, for example. So we now have easy to use vertex map tools within the fields. And that's also very nice. But I actually wanted to show you the growing effect, or the growth effect. So we've got this freeze layer here, and this freeze layer stores this selection. There's one thing in the layer tab of the freeze layer that is very interesting, and that is the mode parameter here. And once you set this to grow, it will have a look at a radius, and if there's another vertex or point inside of that radius, it will give that point a weight. And if I press play now, you see that the whole thing grows. Maybe let's increase the radius to 20 and also reduce the effect strength. The effect strength reduces the speed of the effect, so to speak. Okay, now we have that growing vertex map, but I want to add some more detail. So what I can do is I can go to the radius tab here, for example, and create a new random field. Then this is what happens. Okay, let's adjust the random mode to be noise. We've got a Perlin noise here, and we want to increase the scale to, let's say, 400. And then we've got a vertex map that grows like this, which is already very interesting. One thing I don't like about this vertex map is that it has very sharp edges here. So let's try to blur that vertex map. And now I show you something that is really cool, because what you can do is you can reference a vertex map in another vertex map and then do some stuff with it. So let's copy this vertex map. Maybe let's rename it and name it vertex map 1. Copy it over. Let's call this vertex map 2, blurred. And let's go to the Fields tab here and delete the freeze field. So what we can do now is we can drag and drop the first vertex map into the field list of the second vertex map. And when we press play, we see if we switch between those two, they are exactly the same. But what we can do now is, for example, we select the vertex map field here and adjust the mode from nearest to be average. And this will blur the vertex map, again, based on the radius here. And as we bring down the radius, let's say to 15, we've got this. Or maybe let's use 20. No, 15 is OK. So now, as we hit play, we see we've got a sharp growing vertex map, and we've got a blurred vertex map. Now let's create another one, also based on the first one here. But let's copy the second one, and let's invert this thing. And this can be done very easily, either by going to remapping. Let's see. No, this seems to be the wrong way. OK, we do it differently. We use another invert layer. So what we have here are 3 types of fields. Field objects that really come as separate objects in the object manager and in the viewport. Then we've got fields that rely on other objects. And we've got modifier layers. And these are like adjustment layers in Photoshop. So what you can do with them is you can remap the values of the fields that you created before. And here we just use the invert field. And as we press play, we've got the first vertex map, which is the sharp one again. The second one is the blurred one. And the third one is the inverted one. I rename this inverted. So we've got these 3 vertex maps. Now we want to use them. Okay, first I want to deform the plane here. And I use displacer for that. So here we've got a displacer. I hold down Shift to make it a child directly. And in the shading tab, I add a color shader, which is set to white by default. That's why the plane came up here a bit, because it's displaced. And then in the fall off tab, we use the blurred vertex map and press play. So right now, we are masking the displacer by using the vertex map we created before using the fields. So maybe let's fine-tune this a bit and add some spring effect. Therefore, we can add another modifier layer, which is the delay modifier layer, which is actually pretty much the same as the delay effector, but as a field. So let's use this, and let's set the mode to spring. And then you see that it's growing up, but it does not overshoot because the whole list is clamped to values between 0 and 100%. But there's this other button here, which says clamping, that we can disable, and now the list is unclamped, and the values can go beyond 1 or 100% or below 0. And this way we create a nice spring effect here. So let me enable the cloner. And now you see, it's already a really nice effect. But I want to use the vertex maps even more. So let's create some scaling that is based on the vertex map here. OK, therefore, let's select the cloner and create a new plane effector. And in the plane effector, we adjust the parameters a bit, disable position. We only want to use scale, a uniform scale, which is set to relative scale, which means we need to scale by -1 to scale them down. And now we want to assign a field to this, and in this case, we need the inverted version of the vertex map. And there we go. So now we are controlling the displacement of the plane as well as the clone size by using the vertex maps here. OK, maybe let's do some remapping here. And this can be done by adding a modifier layer, for example, the curve. And then we've got this curves adjustment here, and we can bring in the dots here a bit to increase the contrast in the weight map, so to speak. So this is the effect that I like to have. And now the only thing that's missing is the outline here. So I want to create an outline, and this is based on a shader, actually. So let's open up the material here, and in the luminance channel, let's get rid of everything I have inside here. So you see that there is some luminance going on. And in order to use a vertex map in a shader, we need a vertex map shader. So let's create one. In the effects menu, there is the vertex map shader. And when we open it up, we can drag and drop a vertex map in here. And now you already see that the luminance is restricted to the area here where the clones are. So what can we do to create a line out of that? We can actually color remap this. And therefore, we could use a colorizer. So let's use the colorizer. You see that the whole thing is colorized and adjusted a bit. Let's get rid of the red knot here. And let's copy over the black one. So if we've got a fall-off like that, maybe let's turn that into white and bring the knots closer together, just like so. And here we've got our outline. So press play, and here you go. So you see, with fields in vertex maps, we can control even more than just clones, deformers, and so on. We can really control everything because you can use vertex map almost everywhere inside of Cinema 4D. That is really powerful. Okay, the next topic would be polygon selections. So I create a new scene and I want to show you how to control polygon selections. We want to make this sphere an icosahedron and increase the segments. Then make this whole thing editable and select a polygon and set this selection. So now we have a polygon selection. We also create a material and apply it to the polygon selection. So this is what we have now. Okay. Inside of the polygon selection, guess what? We also have the use fields checkbox here. So let's enable this. We again have the freeze field here, which stores the current selection. We can get rid of that, no problem. And maybe let's add a spherical field. Bring it to the outside. And what you see here is a dynamic polygon selection. This works with all kinds of selections, also with point selections and edge selections. Let's say you want to select polygons randomly. Simply create a random field, and there you go. This is a random selection. Now it's on top of the spherical field. Maybe let's adjust the blending mode of the random field to multiply, and this way you would have the randomness applied only in the area where we have the spherical field, and we can move it around. And this is a very cool thing. Another thing that we can do is we could select every second, every third, every fourth, every nth polygon. And this can be done by using a formula field. So I know that many people are afraid of the formula effector and also of the formula field, but actually they are really powerful and worth looking at them. So let's create a formula field. Here's the formula field, and we've got this intimidating default formula. And this is what happens to the polygon selection. So we got this sinus animation going on. Maybe it's useful, maybe not. Let's adjust the formula. Underneath the formula, we have this triangle here, the group that says variables. And here you have a list of the things you can address using variables. And one of them is the component ID. In case of the polygon selection, the ID means the polygon ID, which is very cool. So if we adjust this formula and type in ID equals 0, we select only the polygon with the ID 0. If we set this to ID 10, this is the polygon with ID 10. 100. Let's search for it. This is the polygon with the ID 100. But we can also use other operators here, not just an equals sign, but for example, ID is bigger than 100. Then we've got this. Or smaller. Sorry? Smaller. Then you've got this. And there is another thing that you can do. Actually, I show you a little tip. Because when you go to show help, this is the German documentation, but it doesn't say that there is a documentation of all of the operators that you have. But you have them in the formula effector. This is still something we have to add to the help files there. So if you go to the formula effector and right-click on the formula and say show help, then you scroll down, and here you find a link to the list of all possible functions and operators and so on. This is everything you can use inside of the formula effector and also inside of the formula field. So there is this function called modulo. And the modulo is actually, well, if you divide a number by another number, and you are in primary school, and you don't like decimals, and you don't know what decimals are, what did you do? For example, well, the challenge is to divide 4 by 3. So what you actually do is you divide 3 by 3 equals 1, and then you've got 1 left over. If you divide 5 by 3 equals 1, but you got 2 left over. If you divide 6 by 3, it's 2, and you've got 0 left over. And if you continue that, you've got a row of 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. So we can use a modulo function in the formula field, which goes like this, modulo, and we want to divide the ID of the polygon by 2, and if the result is 1 or 0, we have to define that, equals 0, then you will select every second polygon. And this is a very cool thing. If we divide the ID by 3 and make the modulo of that, this is every third polygon. And so on and so forth. So this is every 10th. You get it. And another thing that you can do using selections is you can use a bevel deformer and create cool procedural bevel effects. So let's select the sphere and let's create a bevel deformer. I hold down Shift to make it a child immediately. And then we adjust the component mode to be polygons, because we want to bevel polygons. And we drag and drop the selection that we created using fields with the formula field here into the polygon or into the selection field here. Well, then we can adjust the extrusion to go to the inside and maybe turn on some screen space ambient occlusion. And then you've got this here. So it's every third polygon that was selected dynamically. And then I used this selection in the bevel deformer. Very cool thing. And you can create other really cool things with that. For example, a Pong game. So this is a small dynamic setup that I created. And I can play Pong now. So this is just a polygon selection. I can show you the setup here. Here are the fields that create the pixels. And I can also turn on trails here. This is just a decay field. So look at this. It's very easy to create and very much fun to play. Unfortunately, I didn't figure out how to create a multiplayer mode. But anyway. Okay, next thing. Let's see. So what I showed you now was various use cases, but there are some more. You see it here? I've got one spherical field, and I've got a MoGraph setup, a deformer setup, a vertex map setup, polygon selection, point selection, volumes, and also dynamics. And once I move the spherical field here through all of these use cases, this is the very same spherical field here. I can control all of that. So let's bring it to the dynamics. Now I have to press play. Bam. I'm controlling forces using the fields. So everything can be controlled using fields. It's a unified weighting system all over Cinema 4D. A very powerful tool. Check it out, really. All right. But there's more that you can do with fields. You cannot only weight stuff and apply colors to it or some transformation. You can also control directions using fields. So right now I've got a spline, and I've got all of these arrows, which are MoGraph clones, and all of them point to the closest point on the spline from their position. And you can create an effect like that. So maybe let's recreate this whole thing. Okay. Let's turn off depth of field in the viewport here. So this is our initial scene. We've got a lot of arrows. And the first thing, oh, let's get rid of the plane effector as well. The first thing I want to create is a target effector, because the target effector is the only effector that can really control the directions of a field. So let's create this. And now you see what the target effector is capable of. Everything can point to one point in 3D space, which can be cool, but if you need the arrows to point to the closest point of a surface of another object or a spline, you need to use the field directions. So the first thing we need to adjust inside of the target effector is the target mode needs to be field direction. And for later, we also want to reverse the heading. OK, then inside of the fall off tab, we drag and drop. Oh, no. I deleted the spline. Well, I will create a new one. OK, let's do this in top view. So let's use this. So here we've got a new spline. All right. So we drag and drop the spline into the field list here. And you see that there is something happening immediately. So there is one thing that we don't need. Actually, there are more things that we don't need. First of all, we don't need the values to be modified. We just need the directions to be modified. And now you see that the arrows are following the spline here. If you watch closely, they are following the spline. But we want them to point towards the spline. Maybe I should also move the spline up. That's something I forgot. All right. And now, in the target effector, select the spline field and adjust the distance mode to be radius. And immediately, oh, now they are pointing away. We have to reverse the heading. And now they are pointing towards the spline here. OK, and as I move a point on the spline, let me find one. Here we go. They are all realigning. OK, now let's add a plane effector to adjust the scale. And we want to disable position. We just want the scale to be modified. And now they are all gone, because we don't have a fall off yet. Again, let's drag and drop the spline into the fields list. And you see that the arrows are now scaled along the spline again, because that's the default of the spline field. Let's adjust this to be radius. And let's increase the radius. Look at this. Very cool, but it's actually the inverted result of what we actually want to achieve. So let's go to the remapping and just invert it. And here we've got our setup. They are all pointing towards the closest point of the spline from their position. So here's another thing. You don't have to use splines, of course. Maybe let's deactivate the spline fields here and add a random field. A random field. And now they are pointing randomly into every direction. But we can adjust the random mode again to be noise and scale up the noise a bit, maybe to 400. Or maybe even bigger. Let's say 600. And then you've got this. And if you increase the animation speed, let's say to 50%, and press play. Oh, maybe let's bring up the scale a bit more. You've got this. So all of the arrows are pointing towards the brighter spots inside of a noise. And the noise is actually a three-dimensional effect. It's in 3D space. And yeah, this is why the arrows point towards different directions, but yeah, the splines that are neighbors, or the arrows that are neighbors to the other arrows, almost point into the same direction. And we can use the same random field in another effector, which can be the plane effector. So let's use it here, and then you've got this. Then they are also scaled based on the noise here. Really good effect. Okay, so the next thing I want to show you is volume modeling. And volume modeling is quite exciting. Let's create a new scene for that. And let's create a few objects, maybe a cube with some very small fillet, and also a sphere, which we can scale up a bit. And then let's have a look at this new menu here, which is the volume menu. I'll undock that because we need it a few times more. And we create a volume builder. So now we've got this volume builder. And as soon as we make these two objects a child of the volume builder, we create a volume, or we create a voxel grid of that. And voxels are actually just like pixels, but in 3D space. Pixels are, well, actually a 2D grid of values. And voxels are a 3D grid of values. And you can see this grid structure here in the viewport representation. And inside of the volume builder, we can bring down the voxel size, and this way we can increase the resolution. Let's bring it down to 2, for example. You can select the objects here inside of the volume builder and make some adjustments, like let the sphere be a perfect primitive. And we can also apply different modes here. So by default, it's set to union. So these are like Boolean operations. But we can also set it to subtract. And now we subtracted the sphere from the cube inside of the volume. Or we can make it intersect. So, and in the end, if we want to render this, because volume modeling is a modeling tool, as the name says, we use the volume measure and make the builder a child of the measure. And now it is a mesh. And this can be rendered. Okay, so let's jump back into the keynote and let's have a look at this guy here. So we want to create this almost from scratch. So what do we have here? We have two types of structures. We have this wire-like structure here that gets thinner towards the middle, and then we've got this other object, which is green, and this object has got holes, and then there is, well, there are wires that are on top of the other object, and some wires go below this. So, how can we do this? Let's jump back into Cinema 4D, and I already prepared a scene, which is the dual mesh start scene here. So, this is the geometry I want to start from. And first of all, I want to create that wire structure. And therefore, I create a cloner setup where I clone some splines onto the edges here. So let's create a spline. I use the arc spline. Let's bring it down to 15. Set the start angle to -90, end angle to 90. And the plane should be Z and Y. And then I want to clone this using a MoGraph cloner. Hold down Alt to make it apparent as you create it. And we want the mode of the cloner to be object, because we want to clone on an object, and the object should be the cylinder here, or the modified cylinder. So let's drag and drop this in. And by default, the splines are distributed over the surface here. Let's adjust this to be edge. Now they are distributed on all of the edges, but they don't match the vertices here from the mesh. So let's enable scale on edge and bring this up to 100%. That's it. So now we've got some splines that are that have their starting and their endpoints on the vertices of the mesh, but they are all pointing outwards. That's something we don't like. We want some of them to point inwards. The best thing would be if every second one would point inwards. And guess how you could do that? Using the formula effector. But this time, the formula is as easy as can be. It's not empty, but it's very easy. So let's create a formula effector. And here we go. And now there is some weird stuff going on because of the default formula and because of the settings here in the parameters tab. Let's disable position, let's disable scale, and let's enable rotation and set this to 180 degrees. And now, as we play, we see, okay, there is still this weird animation going on, but it's doing the right thing, actually. It turns around by 180 degrees, but this is animated at the moment. So how does the formula effector work? Actually, the values that you set up here in the parameters tab will be multiplied with the result of that formula. That's it. And every single clone comes with an ID. So what we can do here is we can simply type in ID. And now we got what we want. Why is that? Because we got clone 0, and 0 will be multiplied with 180 degrees equals 0. Then we got clone number 1. 1 times 180 is 180. Then we've got clone 2. 2 times 180 equals 360, and so on and so forth. And this way, we've got every second clone rotated by 180 degrees. OK. Now let's create some holes here inside of the Polygon object. So how can this be done? By using one of my favorite tools inside of Cinema 4D, the Voronoi fracturing. This is a really great tool, and you should really dig into this tool because it's so powerful. OK, let's create a Voronoi fracturing object, and let's make the cylinder a child of it. And by default, there is a point generator here, which creates random points somewhere here, and based on that points, the fracturing pattern will be created. But what if I put the cylinder here that we are going to fracture as a source object? Look at this. Here I can explain you how the Voronoi fracturing algorithm works. So basically, if I select this, you see these points here, the green points. If I use the Polygon object here as a source, it will create a Voronoi point on every single vertex of the Polygon object. And the Voronoi algorithm then creates a cut directly in the middle between those points. So I've got a point here, and I got a point here, and here is the cut in the middle. I've got a point here, and I've got a point here, and here is the cut in the middle. That's how it works. OK, let's go to object, and maybe let's create an offset of 3. And now you see, even better, what happens. We are creating an island around every single vertex here. So everything we have to do now is to invert that whole thing by checking invert, and there you go. So now you have a polygon mesh, which is green at the moment, and you've got a spline setup, and those are not intersecting. Really cool. OK, let's enable the lines here to see how the mesh looks like. We want, or later, we want the volume to be based on mesh points. So at some point, we have to subdivide this geometry here. And I want to use detailing for that, because it's already part of the Voronoi fracturing. We just enable it, and bring it down to 5 maybe, so we've got more resolution here that we need later. Okay, so this is our basic setup, and now we want to create volumes out of that. So let's hide this structure here and start with the spline setup. We create a volume builder and make the spline setup a child of it. So this is our setup. We need to increase the resolution, which means we need to lower the voxel size. What's up here? Okay. Then we select the cloner here inside of the volume builder and bring down the radius maybe to 3. Then we've got some dots here because the volume builder creates spheres on a spline basically. So we need to increase the density, and now we have that structure here. Let's create a volume mesher to mesh this whole thing. So this is our mesh. Maybe we can also add a smooth layer. So now by default, the whole thing will be gone because the smoothing is too strong. But we can adjust it. Maybe we go to mean and decrease the voxel distance here. And then we've got thinner lines here. But here in those areas where the splines touch each other, we've got a very nice blending. Okay, that's the basic setup for our, well, wire mesh, so to speak. Maybe let's create a small material, maybe something reflective. Let's get rid of this layer here and add another GJX. Adjust the Fresnel to be a conductor. So we've got a metal material and increase the roughness. And let's assign this to the mesh. And then it looks like this. And then we turn back on the Voronoi fracturing setup and create a volume out of that. So select the Voronoi fracturing, create a volume builder, hold down Alt in order to make it a parent immediately. And let's decrease the voxel size again. And here's the reason why I subdivided the whole mesh. And this is because by default, the voxels are just created on the surface here. But if I click or select the Voronoi fracture here inside of the volume builder, I can enable use mesh points. And if I do so, I can control the point size with the radius parameter here. So I can bring this to 6, for example. And then I've got a volume like that. Mesh that. Then it looks like this. Maybe we should smooth this one also, and then it looks like this. So a very, very nice effect. Let's create another material here, maybe some greenish one. Here. And we could say that this is finished. But we can also continue because we have some minutes left. Because one of the very cool things about volumes, and particularly about the filters here, is that you can mask them using fields. So if we created, in the volume builder of the wire structure here, if we created a reshape layer, and reshape layers actually make objects bigger or smaller depending on the normal direction. So they move the surface in normal direction. And with the reshape layer selected, we can go to fields here and add a spherical field, for example. And then you see, that you can move this around. And you can also invert the spherical field here, for example, or scale it up. and you can create really nice effects with that. Maybe also here in the volume builder of the green object, let's add another reshape layer, and let's bring in the very same spherical field. But this time, I want the reshaping to be negative, like -3, and then you've got this underlying or this green object just in the areas where the wires here are thin. Okay, and now you can move this and create cool motion graphics with that, and it all reacts. So, because I have 4 minutes left, I hurry up. I create something very fast here because I want to show you one last thing. If you create a random field, maybe let's set it to be a noise, and let's scale it up to 1000. And let's create a volume builder and set it to fog volume, so you can have sign distance fields, which are good for modeling, and you can have fog fields, which are actually good for rendering fluids and stuff like that. Decrease the voxel size and just import the random field here. And then you see that the volume imports the data of the random field. And guess what? We can mesh that. We can mesh noises, which is awesome, because now we can animate the noise here, for example. And it all reacts. We can adjust the type of the noise to like SEMA. Maybe we have to make it bigger, and we've got something like this. So, very powerful tools, and the fields and the volumes work hand in hand. The combination of those things is so powerful, you really have to try it. Okay, I could show you some more stuff, but I have to come to an end because my hour is over. So thank you very much. Thanks for listening. Thanks for not falling asleep. And yeah, I hope you can use that knowledge and create stunning effects. Thank you.